Hey guys, this video is going to walk you through a couple examples on 11.6. This is a pretty quick lesson. We're just going to be utilizing this one theorem called the chord-chord product theorem. So remember that a chord is a segment within a circle whose endpoints lie on the circle. This could also include the diameter, but remember it has to pass through the center of the circle to be a diameter. So the chord-chord product theorem says that we can take the two smaller segments of a chord and multiply them together, and it's equal to the same as these two segments multiplied together. So product means to multiply. So we are multiplying the segments that make up the chord and setting it equal to the other segments being multiplied as well. So I think this will make more sense looking at an example. So they want me to find the value of x and the length of each chord. So here's a chord and here's a chord. So the product means I'm going to multiply those two segments that make up that chord CD. So I'm going to take 8 times x, and I'm going to set it equal to the product of another chord within that same circle. So AB is made up of the two segments 6 and 5. So I'm going to find that product. So product theorem with two chords. So 8x then is equal to 30. So if I divide by 8, I will have my value of x. So if we do 30 divided by 8, 3.75 is our value for x. Okay, so I found my value for x, so here's kind of part one of the answer. The other part says the length of each chord. So CD, that chord, is equal to x plus 8. So I would do x, which is 3.75, and add 8 to get that whole length, which is going to be 11.75. So there's one of the chords. The other one is AB, which if I add those two segments, I've got 6 plus 5, which is going to equal 11. So I've got my value of x and the length of each chord. Sorry, cut off the screen again on you there. So we added the two segments together to get the whole length of each chord, use the chord-chord product theorem to get x. Next example, same thing. We can use this theorem to find kind of missing pieces as well. So in this one, we're going to calculate the original diameter. So we have this chord AB. It's a perpendicular bisector. So that means that these two lengths are going to be the same because it's being bisected. And perpendicular gives me that 90 degrees. So I want to find this because this would give me the diameter if I could add 3 plus x. So I need to find x. And if these are both 5, I can take the product of 5 times 5, so this chord, taking those two pieces, and set it equal to this chord, its two parts multiplied together, which is going to be 3 times x. So 25 equals 3x. Divide by 3 to get our x value. That leaves us with 8.3 approximately. So once I have my value for x, then I can find its diameter. So remember, if a chord is a perpendicular bisector of another chord, it has to be the diameter. So PR is equal to this 3-inch segment plus that value of x we just found. So if I add those together, PR is going to be 11.3, and our units here are inches. So that is the diameter of that original disc that they only had a section to find. All right, that's the chord-chord product theorem in use. Thanks for watching.